Here we go, friends. The last review lesson that you have to deal with from me this school year. Congratulations on making it this far. The first thing that I want to talk about, which we didn't specifically talk about in Unit 11, but you just got to know how to do it. Isolating variables. Isolating meaning get it by itself. And this is something that I'm hoping you're comfortable with doing, because the big idea is that we're just going to be working with inverse operations. Inverse meaning opposite. So let's say I have x squared y divided by m plus z equals n. Sure. And let's say we are going to, let's isolate x. Well, get x by itself. We're going to start moving what is least attached first. So x squared y over m equals n minus 7. Now we're going to multiply both sides by m. So those will cancel. Get x squared y equals m times n minus c. And I'm just going to leave it like that. Going to divide by y. And now we're going to square root. So basically when I say take care of what is least attached, I basically just mean the opposite of order of operations. Yeah, so just kind of working backwards. Just wanted to review it once so you could see what was going on. Okay, let's talk about some volume stuff. What I'm hoping you gathered from our volume lesson is that it's always the base shape, the area of the base times the height. Well, for a cylinder, the area of the base, pi r squared, which is a circle, times the height. So there's volume of a cylinder. If I had a cone with that, all we're doing there is we're going to divide it by 3 or multiply it by 1/3. I get that. Same thing with, if I have a rectangular prism. I get length times width times height. Well, if I was to take a pyramid, and let's say we got length times width And then we're going to say all of that is the height. Same thing, I'm going to divide it by 3, or I'm going to multiply it by 1/3. Those are the same things. And so from there, it's just plugging and chugging. Yeah, I don't think I need to do an example. If you would like examples, please go to the lesson for 11.1. Okay, let's talk about probability. More specifically, we're going to talk about two-way tables. Okay, here's a fun one I would have done in class with all of you. You know, every class, we got boys, we got girls, and then I'm going to show you a picture of the dress. And if you don't know what I'm talking about with the dress, remember it was black and blue or white and gold. Here, I'm going to give us some more room there. If you're not sure what I'm talking about, just Google the dress. It'll show up. So let's say some of you would see black and blue. Some of you would see white and gold. So let's say we got a class of 30 people. And let's say that 19 people see black and blue. And 11 people are wrong, aka they see white and gold. And let's just make up some numbers here. Let's say we got 11 and 8. And let's say 4 and 7. There we go. Okay. So just some notation. Okay, first, the probability that we pick a boy at random. Well, how many boys are there total? 18 out of 30. And I could reduce that fraction, or I could give it to you as a decimal or a percent. I think today I'm going to choose decimal. Actually, it's going to be percent. Okay. Probability that someone chosen at random is a girl. Well, there are 12 girls out of a total of 30. So that should become 40%. Another way we could have written that, remember that's the complement of being a boy, or another way you could have seen that, at least we saw it in math space, the boy prime. So the opposite of boy, which was girl. So that's the 40% there. The probability that someone was correct, aka they saw black and blue, is 19 out of 30, which is a 63%. And then I could get a 37% for being incorrect, aka white and gold. But I want to spend more time on like a combination of categories. So what is the combination? Well, what's the probability that you're a girl and you see white and gold? Yes, let's remember this means and. So a girl who also sees white and gold, well, that's 4 out of 30, because we're still out of totals here. So we get a 13.3%. Or maybe the probability that you're a boy and you see black and blue. Well, the combination of the two is 11 out of our total 30. which we get a 36.7%. The probability that someone is a girl or they see black and blue. I'm going to erase these here for a second, just so they're not also highlighted. Okay, so the probability that someone is a girl, well, I see that's 12. And the probability that someone sees black and blue is 19. But notice, if I just add those together, I have double counted this group here. So I actually have to subtract that 8 because 8 has already been accounted for in either the girls or the black and blue. So 19 plus 12 minus 8 is 23. And we get a 76.7%. Okay, I would like to look at 2 examples. I'm going to erase these. 2 or more of some conditional probability. So maybe the probability that someone sees white and gold given that they are a boy. So remember, this conditional probability is the only time the total changes. So everything else was out of that 30, but as soon as I have conditional, the total number of boys I have is the total I'm going to be looking at because I'm only looking at the category of the boys. So, how many boys are there total? 18. So that means I'm going to be looking at 18. So out of those 18, how many saw white and gold? 7. And we're going to get a 38.9%. Let's do another one. Let's do the probability that someone is a girl given that they see a black and blue dress, aka given the fact that they are correct. This is going to be my total here. So how many people see black and blue? 19. Well, out of those 19, how many are girls? 8. So I get 8 out of 19. So we get 42.1%. Okay, so let's talk about independence. And for that, I'm going to need a probability that someone is a girl again, which was 12 out of 30, which was 40%. I'm just going to erase these so they don't get in my way. Is being a girl independent from seeing a black and blue dress? Well, here's what you need to know about independence. 2 events are independent if the probability of event A is the same as the probability of event A given that it has any condition on it. So basically, whether this event has a condition or not, the probability should be the same. And so I can look at these 2 probabilities here. So probability of being a girl was 40. and then we had a 42.1. And so if we're being very technical, since those do not equal each other, they are not independent. But also, these two percentages are so similar that we could argue that the two events are independent. And so you might be going right now, well, Miss Lambert, which one is right? Well, here's the thing. As long as you're justifying your answer, then I would count either of these options correct. I would say for it to be so close, like at least on the homework for 11.4, some of you were saying, oh, they're really close, but they were over 10% difference. Like, that's not close. Like, close I would almost argue that close is within like 3%. Anything more than that, I would say that they're more not independent. So, yeah, those are close. Basically, as long as you either of these answers I would consider correct as long as you justified why.